In this video, you're going to convert the file size number you calculated in the previous video to bytes. So let's go ahead and do this. So first of all, I'm going to create a string, call it units, where I'm going to store all the possible units we may have. So bytes, kilobytes, megabytes, gigabytes, and petabytes. So these are the different possible units you may have there. All right. And now we need to convert this number to the correct number of bytes. So let's create a variable file size bytes, which is going to be returned in the final array. So this variable is going to store the size in bytes. So to make things easy, let's have a look at a few scenarios and see how the conversion works every time. So if the file size is in bytes, like that one, then 10 bytes, for example, would be converted to 10 because it's already in bytes, right? Now, if it's in kilobytes, then 10 kilobytes is going to be 10 multiplied by 1000. So again, this could be 1000 or 1024, depending on what system you're working with. So in my computer, it is actually 1000. So this is something you can check. So you can check that by checking one file and getting the info of that file. So if it says on your computer 1.6 megabytes, you can get the info of the file and see how many bytes you've got inside. So if it's that number multiplied by 1000, then your system is following the 1000 rule. Otherwise, it's going to be 1024. Okay. If it's in megabytes, then 10 megabytes is going to be 10 multiplied by 1000 multiplied again by 1000 to get bytes. Okay. And let's do this for gigabytes. And here you're going to get another multiplication of 1000. And finally, for petabyte, you get another multiplication by 1000. So let's see the pattern here and try to find a way to program this using our string units. So you can tell that in the first scenario, we are just using the same number. In the second one, we are multiplying the size with 1000. So we multiplied by 1000, okay? And that's what we did. Now in this scenario, we multiplied actually by 1000 to the power 2, right? Isn't it? And in this example, we multiplied by 1000 to the third power because we multiplied 3 times by 1000. And in this one, we multiplied by 1000 to the fourth power. So let's see the relationship between the number of times or the power and the index of the units inside the units string. And by the way, here we multiplied actually by 1000 to the power 0, which means 1. Okay? So the first one is the same actually as the index of that unit, B. And this one is the index of K. And 2 is the index of M, isn't it? Great. So this is starting to make a trend here. It still works with G. That's the index of G in the string. And 4 is the index of T inside our string. So basically what we're doing, we are multiplying the size in numbers, which is file size number. We're multiplying that by 1000 to the power, which is the index of the units. Great. So let's convert this to code. So we take the file size number and we multiply that with the power of, or 1000 to the power index of our units. So to guess the index of the units, we're going to go to the string units and then index of the units, and we stored the unit right there. So let's console.log this and see if we get the correct number. So for 1.3 megabytes, we get 1.3 multiplied by 1000 twice, and this is the correct number. Now we are missing something in our code. When we got the file size number there, the results we got there is actually a string. So we still need to pass this as a float number by using pass float. Now we are sure that we are manipulating a number later on rather than letting JavaScript coerce the number for us when we do our multiplication. Now let's try again. So 484 kilobytes is giving us 484,000 bytes, and that's correct. Okay, so this seems to be working. And we've got the correct size in bytes. All right, now let's go back to our main content.js file and change the HTML content of our table row, because as we said, we will need to place the size somewhere so that we can use it later on to reorder the rows. So to do this, you can follow a good practice, which is to add attributes to your HTML tag. So our tag is the table row, and I'm going to add a data name for the name of the elements, and also I'm going to add a data size for the size. So the name is going to be the item variable, and the size is the size in bytes which we received from our calculate size D function or calculate size F function, depending on whether we've got a folder or a file. So let's have a look at the data name. So it's the item variable, and the data size is going to be item details dot size. Now, if you want to make this consistent, you can still define another property, item details dot name, which you can set at the top to the value of the variable item. Okay, and you can create that at the very top like that, and we don't need these anymore. And let's delete this as well. So we are storing the item details in an object. And if you remember, we did that to avoid all the block scoping issues we had earlier. So instead of having to define different variables outside that scope or those scopes, we just created an object right there, and then we kept adding properties to the objects, and that's a good practice which will save you time and make your code more readable. Alright, now let's try our code and make sure that everything works. So if I inspect this table row, for example, then I can see that we've got some data attributes there. So that's our data name just there, and the data size is right there. So this is not really the data size we wanted, because we wanted the data size in bytes. So let's have a look at what we put in there. So we put dot size, and we need actually dot size bytes. So let's correct that. So let's try again. So we're looking at folders only. So let's look at this one. So the data size at the moment is showing there as 1 million bytes, which is correct. So let's check this one. And the data size shows as 1,100,000, which is correct as well. Alright, now the only thing missing in our table is the time, or the last modified time, which we will need to add inside our code. So again, we're going to use the start, or the starts variable, or the property starts, where we store the starts of our item. So this works the same for files and folders. So we will do that outside our if statement. So let's create a new property for item details and call it timestamp. So to get that, we're gonna go to the starts property of item details. Okay, and we need a property called mTime ms. So this is going to be the last modified time in milliseconds, and it will give us the Unix timestamp. To make our code easy to read, I'm going to write when was the file last changed, and this is giving us the Unix timestamp. Now you need to convert that timestamp to a human readable format like this one. So we're going to convert the timestamp to a date. So what you can do, you can create a new property, date, and convert that timestamp to date. So for this, you can use the date class. So let's use the date constructor and pass this value, and then let's console.log this and see what we get. So this is the format we are getting. It's not exactly that. Okay, so this corresponds to the last item. And just a quick comment, the date you see there is just dummy data we used earlier, right? So this is the correct date, but we still need to change the format. So what you can do, you can use a useful method called toLocalString, which will convert that date to that kind of format. So let's go ahead and do that. To local string or local date string, like that. And let's see what we get this time. So this is the date we're getting this time, which is still different from that one. So let's use local string instead and see what happens. And this time we get the correct date with the time as well. Now, if we go to our data attributes, let's add one more data attribute for the time, and let's call it data time. So we will set this one to the property timestamp, like that. And if you have a quick look at what you've got inside the timestamp, you will find that it's not necessarily an integer. So it still carries something in the decimal part. So you can see that one is not really an integer. So if you want, you can pass it as an integer. So when you define it, you can just pass this as an integer, like that. And this will make sure that you only keep the integer part. Okay. So now we've got all our data attributes, the data name, the data size, and the data type. And we are missing something there in the data type. So, okay, we're missing the double quotes right there. Let's try again. And this looks better. So far, we have been using dummy data in the last modified column. So to use the correct data, we just need to replace this data using the property date of item details. So let's try this. And now you can see the correct data being displayed. So if you go to media, for example, then you can see that these different files, they have different last modified information. All right, in the next video, you're going to move to the calculate size f function, which you will create and calculate the size of elements of type file.